Good evening, friends. This is Dr. Manjunath once again meeting you to discuss something on the important formulas that exist this academic year, especially in mathematics. And I'm here to talk about few questions connected to CET. As you all know that 2 more days left for the CET examinations to happen. In connection to all this, Unacademy is planning to take up YouTube classes like this. We from different sectors, from various arenas, from various places, educators are joining us under one umbrella called Unacademy, and we are trying to focus on the important questions that you need to prepare for this time CET examination. I know that we are all running through a very bad time. COVID has really put us all into trouble, but I must say that keeping all these one side, this year's students have really shown their efforts in putting up their best results, which we saw in the second PU examination. Now, with the same aim, we are hoping that all your CET results will be with the flying colors. Friends, if you like this YouTube channel, please like the button and then subscribe it. This is going to help all of you quite a lot, and there are people like me who will be helping you a lot in giving you plenty of information. Unacademy has done a wonderful job in creating a good structured platform, bringing in experts from different corners of the country. So, without wasting much of our time, I know that it is all precious time for us. I shall be discussing for first half an hour the various formulas that we are going to have it in the mathematics, and a glimpse will be added to you, and I'll be stressing on what you need to focus on and which are all the formulas that you need to give importance to. So this is once again Dr. C.K. Manjunath who is welcoming you for this session. Let's start with the concept of indices. These are all some of the basic formulas that we have learned from 9th standard itself, but majority of them are repeated in the 11th and 12th syllabus. A dot m into a dot n, a power m into a power n is a power m plus n. A power m by a power n is equal to a power m minus n. Please remember, in the second case, m is always greater than n. Third, a power m whole power n is a power m mn. A power n whole power n is a power mn. Then a equals 1 if a is not equal to 0. Actually, I must say that this is not just a, it is a power 0. A power 0 is equal to 1. And a power minus n equals 1 by a power n. Nth root of a power m is a power m by n. Please understand, this is entirely different from what you are seeing here. This and this, both are different. This is nth root of a power m, which is a power m by n. Then AB power m is A power m, B power m. It's not n, it's m. A power m and B power m it is. Then A by B power m is A power m by B power m. One more very interesting, if A power m is equal to B power m, where m is not equal to 0, then A is equal to B. If the powers are same, the bases can be equated only when m is not equal to 0. If m is equal to 0, then it becomes 1. Last, A power m is equal to A power n, then m is equal to n. See, the way we equated the bases, even the powers can be equated. A power m is equal to A power n. Values are same, 2 power 3 equals 2 power 3. These two must be same. 2 power, base should be same here. Then the powers can be equated. This is about indices. So 1, 2, 3, 4, 5, 6 and these two last. Very important, we have used it many places. Let's go into the surds. The surd conjugate of root A plus root B or A plus root B is root A minus root B or A minus root B. And converse, vice versa. Please remember, the concepts are very important here. If A power root A plus root B is taken, its conjugate is always root A minus root B. If A plus root B is taken, its conjugate is A minus root B. Vice versa, when I say this if you take, you can write this. This if you take, you can write that. If A is rational number, root B is a surd, and A plus root B or A minus root B, which is equal to 0, then A equal to 0, B equal to 0. A is a rational value and B is a surd. Then A plus root B or A minus root B, if they are equal to 0, A plus root B or A minus root B, if the surd value is equal to 0, then A equal to 0 and B equal to 0 will be there. Very important term to be remembered. If A and X are rational values, B, root B and root Y are surds, and A plus root B equals X plus root Y, then A equal to X, B equal to Y. A and X are rational values, root B and root Y, they are surds, B and Y are surds, then A plus root B equals X plus root Y, then A equal to X and B equal to Y. Let's see complex numbers. Very important chapter from the point of examination. Lot of tricky questions are there from this, and this chapter gets connected into so many other chapters. You can start seeing it from the functions relations to calculus. The symbol z having x comma y is written as x plus iy. If you want to say it as a complex number, x plus iy will be the format of it. X and y will be real values, and I, which is equal to root of minus 1, is called a complex or imaginary quantity. So if the imaginary part of the complex number is iy and the real part of it is x. So how do you represent a complex number? X plus iy. The conjugate of x plus iy will be x minus iy. Same what you saw just now in surds. The conjugate of x plus iy is x minus iy and vice versa. If z equal to x plus iy, then we have certain conditions. Mod z is modulus z, modulus of x plus iy. Now, how do we write this modulus value? Plus square root of, take both the values of x and y and square it. X square plus y square. X square plus y square you take, add them and take a square root of it. Its value is considered as the modulus value of it. How do you find modulus? Amplitude is z, which is null set, which can also be written as tan inverse of 1 minus 1 by tan inverse of 1 minus y by x. So, modulus and amplitude are the two important quantities of complex numbers. So, normally how a complex number is represented in terms of modulus and amplitude values. Z is equal to r cos phi plus I sin phi. Z equals r cos phi plus r into cos phi plus I sin phi. R is actually the modulus value and phi will give you the amplitudal angle of it. One more. Modulus z is equal to minus z also. If it is there, put it into modulus, it becomes positive. So any negative complex number, take it into modulus, it becomes positive. In other words, it can also be set as z into z, which is equal to root of x square plus y square. Modulus calculation can also be done in this manner. If x plus iy equal to 0, then x equal to 0, y equal to 0. Both x and y are real. If a complex number is equated to 0, then x is 0, y is 0, and both of them are real values. If x plus iy equals p plus iq, then x equal to p, y equal to q. I equal to root of minus 1, which is nothing but I square equals minus 1, I cube is minus I, and I power 4 plus 1. Very important, and we use this in many sums. You will be seeing with some examples what I will be taking today in the class. When we go for solving the problems, you will experience this. I is root of minus 1, I square is minus 1, I cube is minus I, and I power 4 is 1. Summation of two complex numbers mod is less than or equal to individual modulus summation plus z1 plus z2. Individually, when you take this, z is going to be root of x square plus y square. So x1 square plus y1 square whole square root, and x2 square plus y2 square whole square. If you add these two, this is nothing but equal to z1 plus z2, x1 plus iy1, x2 plus iy2. If you add them, you get the same answer. Same way, the product z1 into z2, modulus z1 into modulus z2. z1 by z2 is modulus z1 divided by modulus z2. Three basic operations that you need to remember. These things are okay, so I'll take one last one. There are two major roots of the equation when I say complex number. One is omega cube equal to 1, and 1 plus omega square is always equal to 0. We have used this in quadratic equation as well as in complex numbers, this relationship. Omega cube equal to 1 and 1 plus omega square is equal to 0. Variation, nothing much to talk about, it's directly proportional. These are all the relations which we have studied everywhere. Coming into AP, GP and HP, I'll touch upon very important ones only. The general form of AP is A plus D, A plus 2D, A plus 3D, etc. Its nth term is calculating T of A plus n minus 1 into D. It is the nth term calculation. And if you want to find summation, Sn is equal to n by 2 into A plus n. L is the last digit and A is the first digit. It can also be set as n by 2 into 2A plus n minus 1 into D. This is also yes. So for a series like 1, 2, 3 up to n natural numbers, it is equal to n into n plus 1 by 2. Then their squares, 1 square, 2 square, 3 square up to n square, it is n into n plus 1 into 2n plus 1 by 6. And if it is cubic equation, n into n plus 1 by 2 the whole square. Getting into geometric progression, friends, GP is AR square, AR cube, like this the relationship goes. A is first term and R is the common ratio. The way like you have here, A plus D, A plus 2D, A plus 3D, like that. A is first term and D is common difference. Same way this is the one. And here nth term calculation is A into R power n minus 1. A into R power n minus 1. Sum of the n terms of the GP is Sn is equal to A into 1 minus R power n by 1 minus R. 1 minus R power n into 1 minus divided by 1 minus r. This is when r lies between -1 and +1. If r is greater than 1 and less than -1, then Sn is equal to a into r power n minus 1 divided by r minus 1. Next is quadratic equations. Very important area, quite a lot of sums we get from this. We use this method when we don't factorize it properly. If the quadratic equation cannot be factorized, we use a formula minus b plus r minus root of b square minus 4ac by 2a. If alpha and beta are the two roots of the equation, its summation is minus b by a and its product is c by a. And we need to remember always here, a is never equal to 0. If x squared minus of a alpha plus beta into x plus alpha beta equal to 0, then x squared minus sum of the roots x plus product of the roots equal to 0 is the general form of the quadratic equation. The expression minus b square minus 4ac is called the determinant of equation 1. If a, b, c are real and rational. If it is greater than 0, they are real and distinct. If it is equal to 0, they are real and equal. If they are less than 0, it is imaginary. B square minus 4ac is a perfect square, then they are rational. If it is not a perfect square, then it is rational. See the number of terms that I have used. If the delta value of b square minus 4ac is greater than 0, equal to 0, less than 0. These are the three major properties on which the whole of quadratic equation we solve. Real and distinct, real and equal, real, imaginary. Those three are important terms. Apart from that, if it is a perfect square, they are rationals. If it is not a perfect square, then they are irrationals. Anyhow, this we have already seen in the complex numbers. Friends, getting into permutation, combination. Permutation is n factorial, means n minus 1, n minus 2 continues till the last one. If it is 0 factorial, we say it is equal to 1. And please understand, if it is np0, it is n factorial by n minus 1 factorial. np0 can also be said as just n factorial. So these are all some of the very important combinations that we need to do. Then coming into combinations, NCR is n factorial by n minus r factorial into r factorial. We have few other relations between permutation and combination. np0 equals r factorial into nc0 factorial. Sorry, r factorial into nc0 is np0. One of these formulas will be used today in our calculations. nc0 is equal to ncn equal to 1. See friends, this is very, very important. nc0 nothing but equal to ncn. Both the values are equal to 1. One more combination, NCR is always equal to NCn minus r. If I say 5c3, it is 5c 5 minus 3, which is 5 minus 3 is 2. That is also, so 5C3 and 5C2, they are going to be 1. That's what is the meaning they want to say. NCR plus NC n minus 1 is equal to n plus 1 CR. Please understand this carefully. NCR plus NC n minus 1, R minus 1, you can take R n minus, it is equal to n plus 1 CR. If P and Q are not equal, then NCP equals NCQ. That means P plus Q is equal to N. If NCP equal to NCQ, then P plus Q equals N. These shortcuts you need to remember these. That is why I am saying the formulas plays a major role in majority of why this session is taken for you is, friends, this will separate majority of your formulas. NCR by NCR minus 1 equals N minus R plus 1 by R. Then the total number of combinations of n different things taken by any number at a time is equal to 2 power n minus 1. Binomial theorem. We shall be focusing this in other chapters also. See, one is this, which is already seen. These are all some of the things that need to be remembered always. Going into logarithms, a power x is equal to m, then log m to base a equals x. Log 1 to base a, log 1 to base a is equal to 0, log a to base a equal to 1. If the base and the value is, if they are one and the same, then it is equal to 1. Log m to base a, a power log m to base a is equal to m. Some of the indices, whatever we had learned, same thing is applied here. Log mn is log m plus log n. Product. Division. M by n is log m minus log n. Log m power n is equal to n log m. Log m to base a is log m to base b into log b to base a. Log a to base b is nothing but log b to base a equal to 1. Exchange. Interchange of base and the root values. It is always equal to 1. Log a to base b is written as 1 by log b to base a. Root and the base are interchanged, then they get reciprocated. 9th and 10th are one and the same. It is spoken in a different manner. Log m to base b is equal to log m to base b by log b to base a. Some of these series. Then moving into trigonometry, another important area, friends. Radian measures, we have seen one right angle is 90 degrees, 1 degree is 60 minutes, 1 minute is 60 seconds. One right angle is equal to So pi radians is equal to 180 degrees. Angles that we need to know: sine 0, sine 30, sine 45, sine 60, sine 90. Very well known to all of us. Cos, tan. So in the four quadrants, very important term is this. We use this in almost all parts of trigonometry. First quadrant, all are positive. Second, sine and cosec positive. Third, tan and cot positive. Fourth, cos and sec positive. Then its multiple values. Sine 90 plus r minus theta is sine theta, r minus sine theta. Cos 90 plus r minus theta is cos theta minus cos theta. Tan 90 plus r minus theta is tan theta minus tan theta. So friends, this is another important thing that need to be remembered. Compound angles, sine of a plus b, sine a cos b plus cos a sine b. Sine of a minus b is sine a cos b minus cos a sine b. Cos of a plus b, cos a cos b plus sine a sine b. Cos of a minus b, cos a cos b plus sine a sine b. Sine of a plus b into sine of a minus b, that is sine square a minus sine square b. It can also be said as cos square b minus cos square a. Cos of a plus b into cos of a minus b is cos square a minus sine square b, which is cos square b minus sine square a. Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. Tan of a minus b is tan a minus tan b by 1 plus tan a tan b. Some more angles. Multiple angles. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta, it can be said in three ways. All the three can be seen here. 1 minus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is, please understand, 1 minus 2, this is 1 plus, this is 1 plus cos 2 theta is 2 sin square theta, because 2 cos square theta minus 1, this if it goes this side, it is 1 plus cos 2 theta, which is, this is plus. First one is plus, second one is minus. You can see here only. Then tan square theta is 1 minus cos 2 theta by 1 plus cos 2 theta. Sin 2 theta is equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta equals 1 minus tan square theta by 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Sin 3 theta, 3 sin theta minus 4 sin cube theta. Cos 3 theta, 4 cos cube theta minus 3 cos theta. Tan 3 theta, 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Inverse, sine of sine inverse x is x. Cos of cos inverse x is x. Tan of tan inverse x is x. Similarly, sine inverse of sine theta is theta. Cos inverse of cos theta is theta. Tan inverse of tan theta is theta. Sine x plus cos, sine inverse x plus cos inverse x is equal to pi by 2. Similarly, secant inverse x plus cosecant inverse x is pi by 2. Cot inverse x plus tan inverse x is pi by 2. These are all addition formulas. We have properties of triangles. A by sin A, sine rule it is. B by sin B equals C by sin C, which is 2R. Cosine rule, A equals B cos C plus C cos B. Sorry, this is projection. B equals C cos A plus C A cos C. C is A cos B plus B cos A. Cosine rule, cos A is equal to B square plus C square minus A square by 2BC. Similarly, all these. Looking into the coordinate geometry, you will have 1-point form, 2-point form, midpoint form, section formula. All these that we need to concentrate upon. Very important. Then coming into parabolas, these are all circle, parabola, ellipse, hyperbola, then intersection of straight lines. Friends, all these sums what I am putting it across is very, very important to you. Then some of these mensuration formulas you have already learnt it, like volume of right prism, area of the base into height, volume of right pyramid. See, these things you have already learnt it, but you have to put it across in your mind so well, and this becomes an important aspect. So friends, these are all some of the very basic things that you need to remember, and based on this we are going to solve certain problems. I shall be taking you through another journey now. Some of the CET questions which are going to be very important and essential to you as the exams are fast approaching. First one, the number of elements in the power set containing n elements is. The formula itself says, friends, here, so you can glance through it in a very systematic manner. The number of elements in the power set containing n elements, it is 2n elements. This is the answer. This is the formula that we need to remember. Next, it's a concept wise, it's a conceptual formula, so we should not forget this. Next, if tan A equals minus 3 by 4 and A lies between pi by 2 and pi, what is cos 2A? Friends, cos 2A, you have the formula 1 minus tan square A by 1 plus tan square A. 1 minus tan square A by 1 plus tan square A. So minus 3 by 4 whole square is 9 by 16. So 16 minus 9 by 16, 16 plus 9 by 16. So it is 7 by 25. You need to be very careful. They have just given values with positive and negative symbols putting together. Third, please look at this. We need to calculate the independent term of x. When it is independent, the x need to be made as 0. Now, who can do this for us? Please see here. T of r plus 1 is equal to minus 1 to the power r 20cr into 2x to the power 1 by 2 whole power 20 minus r into 3x to the power minus 1 by 3 whole to the power r formula. So we expand this. Now this whole thing finally leads to x to the power 60 minus 5r by 6. This is the equation. Now to get an independent term, this area has to be made 0. So this whole thing is going to be equated to 0. It is equal to 0. So 60 minus 5r by 6 is 0. That means cross multiply, it is going to be 0. 5r is equal to 60, r equal to 12. So when you put this value into this equation, the final answer what you get is 20c12, 2 power 8, 3 power 12. C is the answer. Fourth one. Hope I'm not rushing quicker. I just want to save the time and so that you all get more number of questions for the solving. 1 plus I whole cube plus 1 minus I whole cube is equal to. We need to expand this. How? A plus B whole cube, A minus B whole cube, A cube plus B cube plus 3AB into A minus B. 3AB into A plus B. Is this clear? A cube plus B cube plus 3AB into A plus B. Similarly, A cube, A minus B the whole cube, A cube minus B cube minus 3AB into A minus B. Now see friends, 1 and we have already learnt it over there. What is I cube value? It is minus I. So we wrote minus I plus 3I into 1 plus I. 3I, expand this. 3I into 1 is 3I. Then 3I into I is 3I square. So 3I square is equal to minus 1. Am I right? So it is going to be minus 3. Hope this is clear to you. Minus 3. Then plus 1. Then minus I cube. See this minus I cube, now itself you can cancel it if you want. So that certain values goes off. Or you can say it as plus I. All together we can delete it at the end. 1 plus I. Again see here it is minus 3I. Minus into minus plus. So plus 3I square. I square is minus 1. So if it is minus 1, already it is minus into minus plus it was. Plus into minus it became minus 3. Now what all got cancelled? Minus I got cancelled with plus I. Plus 3I got cancelled with minus 3I. Now remaining is all numerical values. 1 plus 1, 2, 2 minus. Okay. 1 plus 1, 2, minus 3, minus 3, minus 6. So 2 minus 6 is minus 4. So the right answer is minus 4. Hope this is clear to you. Next, if alpha and beta are the roots of the equation x square minus 3x plus 2, then 1 by alpha to the power 4 plus 1 by beta to the power 4 is quadratic equation sum, friends. So they have given this as the equation. It's a summation. Summation of these two is minus b by a. So minus of minus 3 by 1, which is plus 3. And product of the roots is c by a, 2 by 1 is 2. So alpha plus beta is 3 and alpha into beta is 2. They said us to calculate 1 by alpha to the power 4 plus 1 by beta to the power 4. Take LCM, beta to the power 4 plus alpha to the power 4 by alpha power 4 into beta to the power 4. Now, how do you expand this? This is beta whole square, beta square whole square, alpha square whole square. That is to the power 4 it comes, and here this whole together, this can be written here to the power 4, correct? Now friends, this is interesting. A square whole square, b square whole square it is. So how do you say it? A square plus b square whole square minus 2a square b square. A square whole square plus b square whole square can be written as, this whole thing can be taken as m. So it is m square plus n square. How do you write it? M plus n the whole square minus 2mn. Same thing is written here. Now see friends, this part can again be expanded as alpha plus beta the whole square. See, it is a square plus b square formula minus 2ab whole square. If you square this whole, you get this minus 2 alpha beta the whole square by alpha beta the whole square. Why it was brought to this simplification is because we know these values. Now substitute summation of the roots and product of the roots. When you substitute, get the answer as 17 by 16. 17 by 16 is the right answer. Next, for the inequality x by 3 plus x by 2 is less than 5, the interval is for the inequality value, what is the interval values that can be taken? Now, how do we solve? X by 3 plus x by 2 is less than 5. Take LCM, 3 2s are 6. 2x plus 3x by 6 is less than 5. 5x by 6 is less than 5. Cancel 5 both sides. So x is less than 6. X is less than 6 from where? Minus infinity to 6. Now all are being given like this, but what is the notation that can be used? Only this. Rest all are. See, this is range, this is again a range, and this is not a set at all. We use these three notations. This is going to be used for ranges, and this is the interval in which it lies. It's actually ordered pair, okay, which is not used anywhere. Okay. If NPR is 1680 and NCR is 70, what is the value of N? I had already said we use a formula, NPR is equal to R factorial into NCR. It's that formula. This is where I was telling friends, formulas play a major role. See, we used one formula here, one here, one here. See, this is one formula. Formulas play a major role, see. Without that, no maths exists, friends. In every sum, if there is a formula, things can be used. See here, IQ. Okay, NPR equals R factorial into NCR. So it is 70 into R factorial is equal to 1680. Now what is R factorial? 1680 by 70, which is 64. Sorry, 24. 24 can be written as 4 factorial. If R factorial is equal to 4 factorial, so R equal to 4. So the right answer is, so let's check whether we have done correctly. Answers 7D. Oh, see, they have given the wrong answer. You need to be careful. This is wrong. 6a, yeah, 5b, 4c, 3c, 2a, 1b, 1c. This is the only one which they have given it as wrong. You can also verify it once. If you have any mistakes, that can be checked out. Let's go into the next set of problems. A is 1 minus 1, 1, 1 and find the value of a cube. What is a cube, friends? A into A into A. In other words, A into A, first you do A square and then multiply that with another A, which becomes a cube. So 1 minus 1, 1, 1 is taken and a square is done. How do you do? Row into column. So finally you end up getting 2, 2. 2 minus 2 minus 2, 2. In this you take out 2 common. It becomes 1 minus 1 minus 1, 1. Which is nothing but 2 into A. So A square is 2A. We wanted A cube. Another once more that A square needs to be multiplied with A. A square into A. A square is already, which is 2A. Multiply that with A. Now 2 into A and A is here. Again it is A square, which can be written as 2A. Please understand these two, which is A square. If this is A square, this is again 2A. So 2 into 2A, it is 4A. So the right answer is 4A. So A cube is 4A. A square will be 2A. A cube will be 4A. If A is cos theta, sin theta, minus sin theta and cos theta, then A into A dash is what? See, A is this complementary. You just have to interchange these two. This becomes plus sin theta, this is minus sin theta, which will be A dash. And A into A dash is I. We know very well. This is true even in case of 1001, correct? For your clarification, we can look at it once here. A is this, A dash is this, multiply, see, row into column. It becomes 1001, which is I. Now A is given as 0 minus I and 0, and B is 0, 1, 1, 0. Determinant of A plus determinant of B equal to what? Now these matrices have to be converted to determinants and find the value of it. Principal diagonal minus the secondary diagonal. So when you do that, 0 into 0 minus I into minus I into minus I plus I square. So minus is there. See here. 0 into 0, 0. Minus into minus, it becomes plus I square it is. 1 minus is out because which comes principal minus secondary. If you do product, you get the determinant value. So the value of this is minus I square, which is equal to 1. The value of this determinant 0 minus 1, which is minus 1. So this is 1, this is minus 1. Summation of two determinants is 0. So the right answer for this is 0. Very interesting one. Such simple ones, you should never make mistakes. See, consecutive numbers, when they give, what will be its determinant value? It should be 0. Blindly you can take it. Why? These things are R2 minus R1 they did, and R3 minus R2 they did. R2 minus R1. R2 minus R1. So 1, 1, 1. R3 minus R2. 1, 1, 1. So both are 2. If you have two identical rows or two identical columns, then the determinant value is 0. Friends, when you have consecutive numbers like this, you must remember that this can be made always 0. You should not waste time on such problems. It's very simple. Tuck. You should catch it and solve it. Next, you have a determinant that is given as 20C3, 20C4, all this, and this is 21Cn. 30C5, 30C6, 31Cn plus 2. It's equal to 0 given, and what is the value of n? See friends, I was telling you this is the formula. Why formulas play an important role? Why did I take that half an hour in the beginning for this? It is only for this reason. NCR plus NCR plus 1 is NCN plus 1 CR plus 1. See 20C3, which is NCR, 20C4 is N plus 1 CR plus 1. So when I have this is R, this is R plus 1, this is R plus 1. Please understand this N is equal to 4. You can check in all the things. N plus 2 is equal to 6, so N is equal to 4. N plus 4 is equal to 8, N is equal to 8. Get the answer. So the n value here is 4. This is very commonly asked question, friends. Very common question and very essential for us. 1 plus x, 1, 1, 1, 1 plus y, 1, 1, 1, y, 1 plus. Now what do we do from this? Subtract these rows. Either you can do with row or column, anything is fine. So when you do R1 minus R2, you will have x minus y 0. Same way these two, if you subtract R2 and R3, 0. This will be y, this will be minus z. See this. When you do it, get a simplified determinant like this, expanded, you get xy, xz, yz, which is summation of x plus y plus z and xy. So the real answer is, you can match it, you will get the right answer. last 5 problems to you. The area enclosed by the curve x square equals to 4ay, the x-axis and the ordinates x equal to 0, x equal to 4a in a square unit is. The enclosed area is x square by 4a and the limit tends to 0 to 4a. Integral of x square, see when you have 4a constant, take it out, 1 by 4a. Integral of x square is x cube by 3. And the lower limit is 0 and upper limit is 4a. Substitute in that. 0 we need not worry, only 4a you substitute. 4a whole cube is 64a whole cube by 3. Now here there is one more 4 into 16, it is 16, 16 4s are 64, 1a cancels, it is a square. So 16a square by 3 is the area that is enclosed. You need to be very careful, friends. If you use little bit of common sense, this is the only sum which has got denominator in it, and in the integral value, when there is a cube r square that comes into the picture, 3 has to come into the denominator. This, if it strikes to you, 50% of your problem is solved. The area included between this and this, another equation. Solving those two equations, you get y is equal to 3 and y equals 2. Substitute that in the area value. You get the answer as 27. It's the same sum we are doing it. A committee of 6 to be formed, 6 boys and 4 girls. In how many ways this can be done if the committee contains at least 2 girls? See, 3 ways it can be done: 2 girls, 4 boys, 3 girls, 3 boys, 4 girls, 2 boys. Combinations. 3 major ways. So which are those? 4c2 into 6c4 plus 4c3 into 6c3 plus 4c4 into 6c2. The 6 into 15 plus 4 into 20 plus 1 into 15. 90, 80, 15, whose sum is 185. This is that. The order and degree of the equation. When you see the equation itself, you can say what is it, or respectively. When this is equal to 0, the order of the differential equation is 2 and the degree of the differential equation is 1. 2 and 1. You need to be careful. 1 and 2 is there, 2 and 1. Order and degree, they have said order is 2, degree is 1. Be careful, never make mistakes with this kind of sums. The last question, which of the following is 1, 1? F of x is equal to x square, friends, is not 1, 1 because f of x1 is equal to f of x2. And it does not mean that x1 is equal to x2. If this happens, all maths changes. Similarly, f of x is equals x square minus 1 by 2 is also not 1. So what is the answer? This is not the one, this is not the one, and this is definitely not. So it's only this. So friends, my today's experiment with you and what I wanted to tell you was, be more practical with the formulas that exist. The basic of this content, what you are learning, is formulas. I'm sure Unacademy is doing a wonderful job to all of you to practice this more and more. And we are the educators here to help you to reach to your goals, to to achieve your best success. I'm sure you will all be coming out this year with flying colors, with very good ranks. Wishing you all the very best. Dr. C.K. Manjunath is here to sign off. If you have liked my video, please press the thumb button and do subscribe our channel. Thank you very much. Have a nice day.